Welcome to The Explainer. All right, let's get right into it. We're going to tackle one of those classic Java questions: abstract class or interface. When do you use which? This is one of those questions that comes up all the time. Maybe you're prepping for a coding interview or you're deep in the weeds designing a new system. Either way, you're going to face this choice. And honestly, getting it right, that's the secret sauce to building software that's not just clean, but actually lasts. And look, it's so much more than just remembering whether to type extends or implements. This is about your whole design philosophy. It's a fundamental choice, really, an architectural one, that dictates how all the pieces of your system fit together, and maybe more importantly, how they can change and grow down the road. Okay, to really get a feel for this, let's try an analogy. Imagine you're building a house. An interface, that's your architectural blueprint. It's a contract, right? It tells you what you have to build. You must have a kitchen, you must have a bathroom. But it gives you absolutely no help on how to build them. Now, an abstract class, that's more like a prefabricated house frame. It gives you all the same rules as the blueprint, but it also hands you the basic walls, the plumbing, the foundational stuff that's going to be common to all houses of that particular style. See the difference? One's a pure contract, the other is a contract plus a head start. All right, so let's break it down and put these two head to head. We're going to get into the nitty-gritty, the actual rules of the language. So on a high level, it really boils down to this. An abstract class is all about an is-a relationship. It's for things that are closely related, that share a common identity and common code. And the big rule here, a class can only extend one abstract class. An interface, though, that's about a can-do relationship. It's a pure promise. It says, hey, this class can do this specific thing. And a single class can make lots of different promises by implementing many interfaces. So let's get even more specific. This table is super useful. With an abstract class, you can have constructors, you can mix and match implemented methods with abstract ones, and you can get really granular with access modifiers: public, protected, even private. Now, interfaces, they were the purists. No constructors, no implemented methods, and everything was public by default. At least that's how it used to be, and we'll get to that in a bit. But this classic view really shows you the trade-off, right? The code-sharing power of a single abstract class versus the awesome flexibility of implementing many different interfaces. Okay, so knowing the rules is great, but applying them, that's where the real art of software design comes in. This is the choice every developer, every architect has to make. So let's put you in the hot seat. You're kicking off a brand new project. You know you need to define some common behavior across a bunch of classes. What do you reach for? What's the right tool for the job here, interface or abstract class? Well, here's a little decision guide that can help. The big takeaway is that it all depends on your goals. Like if you're just defining a capability for a bunch of loosely related classes, think things like being sortable or clickable, then yeah, an interface is your go-to. But if you've got a family of classes that are super closely related, like different types of animals that all eat and sleep the same way, then an abstract class is perfect for sharing that common code. And, of course, there's the hard rule. Java only lets you extend one class. So if your class already has a parent, well, the decision's made for you. You have to use an interface to add more functionality. Okay, so you think you've got it all figured out, right? The rules seem pretty clear. And then Java 8 happened. And let me tell you, it threw a massive wrench in the works and started to blur that nice, clear line we just drew. I mean, for years and years, the rule was simple. The line in the sand was drawn. Interfaces were pure blueprints. Just method signatures, no code. Zero. All your shared code had to live in an abstract class, period. And then Java 8 comes along and introduces default methods. And this was a huge deal. All of a sudden, you could write a method with a full implementation, with a body, right inside an interface. Why was this such a game changer? Well, imagine you have an interface used by thousands of classes. Before Java 8, you couldn't add a new method to it without breaking every single one of those classes. With default methods, you could add it, provide a default behavior, and nothing would break. It was revolutionary for evolving APIs. And they didn't stop there. On top of default methods, interfaces could now have static helper methods too. This was another one of those things that used to be strictly class territory. It meant you could now group utility functions right inside the interface they belong to, which just makes for much cleaner, more organized code. So yeah, Java 8 really changed everything. With those two additions, that simple, clean distinction we all knew, it was pretty much gone. It was a total plot twist in the story of Java, and it completely changed how modern developers approach their designs. The impact of this was massive. I mean, the gap between abstract classes and interfaces just narrowed big time. Interfaces became so much more flexible, so much more powerful. Evolving an API became way, way easier. And what you see today is a design philosophy that leans even more heavily towards an interfaces-first approach, all thanks to these changes. All right, so where does that leave us? Let's wrap this up and get to your final takeaway. How should you be thinking about this choice in the code you write today? This quote right here really nails it. Coding in terms of interfaces is one of the best practices for coding in Java. And what that really means is you should think about your system in terms of what an object can do, its contract, not what it is. When you do that, your code just naturally becomes more flexible, easier to test, and less tangled up. So if you remember nothing else, remember these 3 things. 1, start with an interface whenever you can. Define that public contract first. It keeps your options open. 2, use abstract classes for shared DNA. When you have a group of classes that are truly deeply related and need to share core code and data, that's what an abstract class is for. And 3, leverage both. They're not enemies. The best systems, like Java's own collections framework, do this beautifully. They use an interface like list for the contract and an abstract class like abstract list to give developers a huge head start on implementing it. And that brings us to the big question, the one I want to leave you with. With interfaces being so powerful now, is there really a place for abstract classes anymore? Now, the answer is yes. They still have unique things they can do, like holding state and instance variables or having constructors. But there's no doubt the game has changed. The debate over which is better and when is what keeps shaping modern software. And now, you're ready to join that conversation.